In this video, let us discuss about the regularization in machine learning. Now, this is a video that I want to touch base before we move ahead with the next algorithm that we have got, that is the logistic regression algorithm. So let us understand what exactly is this regularization. Now, when I say regularization, it's one of the important concepts in machine learning. Now, we use this regularization technique when we want to prevent the overfit of a given model. Now, what does it mean by an overfit? Now, think about it. Let's say that we have got a student. Now, this student have prepared from a specific textbook. Now, I've got a student one and he has prepared from this textbook. Now, let us assume that in this textbook, there are 50 questions. Now, what happens is this student, when he is given with a test, okay, if you give any question from this textbook, he is going to score 100 out of 100. That means this student one is going to get the perfect score whenever you give any question out of this 50 questions that he has learned from the textbook. Now, let us assume that you give out a new book, or let's say you have got a new questions, okay. These new questions are completely new. When I say very new, they are just the different values from the textbook. Okay, that means if you give a new question which is based on the existing question, now this student one is going to score, let's say, 0 out of 100. So what does it mean? Well, it means that this student one has actually memorized all the questions and all the answers, and he is unable to answer the new question which is related to the question that he has actually learned from the textbook. Even in the case of machine learning as well, sometimes when we perform the training on the machine learning model, it performs really well on the training data. You can think of this textbook as our training data because that is the data which will be with us. So the model behaves really well on the training data, but it does not behave well or perform well on the test data. Now, it means that the model is not able to predict the output when it is dealing with the unseen data or a new data. And in such scenarios, we say that the model that we are working is actually an overfit model. So this problem can be actually dealt with the help of this regularization technique. Now, this is a technique which we can use it in order to maintain all the variables or the features in the model by reducing the magnitude of those variables. So as a result of this, it will help us to maintain the accuracy as well as the generalization ability of my given machine learning model. So let us understand as how exactly is this regularization concept is going to work. So if you remember, when we talk about the linear regression is given by, let's say, y is equal to w1x1 plus w2x2 plus w3x3 up to w1xn plus c. So this is how the linear regression equation would look like. Now, in case of regularization, we are going to add a penalty term or a complexity term to this model. Okay, we are going to add a penalty term. Now, when I say that y is equal to w1x1 plus w2x2 and w3x3, so what happens is in all these scenarios, this w1, w2, w3 up to wn and the c are actually the weights or the magnitudes that we have got in this given linear regression equation or the parameters of this linear regression equation. Now, with this value of y, so if you remember, we have got the value of cost function. Now, let us assume that cost function or the loss function or the evaluation metric, I'll consider it as squared error loss. Now, when I say squared error loss, in such scenarios, squared error loss is given by sigma of I is equal to 1 to n yi minus y hat I whole square. So what is y hat? Y hat is this equation. Okay, this is the squared error loss, which is known as residual sum of squares. Now what we do is for this loss function, we are going to add the additional term. So what kind of term that we'll be adding? It is dependent on the type of regularization that I want to apply. And when we talk about this regularization, we basically have three types of regularization. One is called as ridge regularization. The other one is called as lasso regularization. The last one is known as elastic net regularization. Okay, so these are the three common types of regularization method. So what does this ridge regression? Now this ridge regression is also known as the L2 regularization. So what it does is, here in this technique, whatever the loss function that we would consider, we are going to add the square of my parameters as the additional penalty term. Okay, I'm going to add the square of this parameter value. So here, when we are working with this scikit-learn, we can actually get the same. So by visiting the ridge regression documentation page, and from here you can get to know how does the equation would look like. See, this is the squared error loss or the residual error loss, plus I'm adding alpha times w, that is mod w squared. Okay, I'm saying mod w squared. So in this way, yes, in this way, we will be able to perform the activity of the ridge regression. This is known as the L2 regression or the L2 regularization. Okay. Now here, by applying this L2 regularization, so this will help us to solve the problem whenever we have got the parameters which are more than the number of samples. Okay, in such scenarios, this ridge regression is going to help us. That is the ridge regularization method. Now, apart from that, apart from this ridge regularization, we have something called as the lasso. So if I take you through the lasso, sklearn lasso. So in case of the lasso regularization, so in this case, here we are going to add, yes, we are going to add the L1 component, which is nothing but the absolute values of the parameter values. So we are going to add the absolute values of the parameter values. So this kind of regularization help us to reduce the overfitting in the model as well as the feature selection, because when we apply this lasso regression, at that time, whatever the variables which are not adding any information, they will be completely neglected whenever we are performing the model evaluation. So this is the overall idea between the two types of regularization technique, that is lasso regression and the ridge regression technique. So lasso is known as L1 regularization and ridge is actually known as the L2 regularization. Now to balance both, we have another kind of regularization technique that's actually known as the elastic net. Now in case of elastic net regularization, here this is a combination of L1 and L2. So this clearly says that how does the equation of this elastic net look like. So here I've got the L1 component as well as the L2 component. Depending on the value that I'll be using, so it would decide whether my L1 regularization will have more preference in this or the L2 regularization. So while working with all this regularization technique, we have the respective parameter value, like in this case the alpha, which will help us to decide how much importance that I have to give for this regularization term. So this is about the regularization technique, which will help us in order to reduce the overfit. Now, when it comes to the implementation, it is very simple to what you have seen till now. So first thing is you will just go ahead and import the same. So from sklearn.linear underscore model, I'm going to import lasso, ridge, elastic net. Now, once I import it, maybe we can go ahead and initialize the model. So I'll make use of the default values of the parameters. I'll say lasso, and then we can go ahead and perform the fit on a given data set. I'll make use of the previous code, which we have done earlier. I'll perform the fit on my training data. Now once the fit is complete, we'll go ahead and perform the evaluation. Okay, I'll generate the prediction of the test data. Now once the output generation is complete, next I would go ahead and compute a metric. Now for the demonstration purpose, I'll make use of the R2 score. So I'll say R2 score and I'll find the value with the help of lasso regularization. Okay, so it looks like the previous code is not executed. Let me run all. And in the same way, I'll repeat the same process for ridge. So if I apply the lasso regularization, so in this case, so here the R2 score that I'm getting is 0.86514. Okay, if I apply ridge, I'm getting the similar value, that is the 0.8609. So if I apply the elastic net, which is the combination of L1 and L2, okay, so let's look into the performance. So here in this case with the elastic net, I'm getting the 0.8633, which means in this given data that we are working, regularization has no impact. So this could be another way saying that the model that I have trained is not overfitting. Hence, we are not seeing much of the difference when we are performing the regularization. So this was the overall idea about this regularization. And if you compare it with the previous value, it is 0.8609. So we are getting the similar score, which means there was no requirement of regularization. So overall, for you to remember is that when we talk about this regularization helps us in adding the penalty term, which forces the algorithm to reduce the parameter values, which in turn helping us to reduce the value of error and increase its ability when it comes to generalization of the data set. Okay, so with this, we come to the end of this video. So do check out the other videos in this playlist, that is machine learning series playlist. So you can download the source code by visiting the site manifoldailearning.in. Just go to the site, click on the courses and select the course, that is machine learning and data science, that is machine learning and data science with Python course. Join now for free and you'll be able to access the source code as well. So thank you so much guys, and I'll see you in the next video.